Section 11.3.15-T. A researcher wanted to determine if carpeted rooms contain more bacteria than the uncarpeted rooms. The table shows the results for the number of bacteria per cubic foot for both types of rooms. So here is the carpeted and the uncarpeted. Okay, so the first thing we want to do is to test the statement that carpeted rooms have more bacteria than uncarpeted rooms at the alpha equals 0.05 level of significance. Normal probability plots indicate that the data are approximately normal, and box plots indicate that there are no outliers. So we're going to use the TI-84 to be able to put this information in. Okay, now to test hypotheses regarding two population means obtained from independent samples, we're going to use the following steps. Provided that the two independent samples are obtained by simple random sampling, or the data result from a completely randomized experiment with two treatments, which that is. The sample data come from a population that is normally distributed with no outliers, or the sample size are large. Well, the sample sizes are not greater than or equal to 30, so we got to check that they're normally distributed with no outliers. And then for each sample, the sample size is no more than 5% of the population size, which is the case here. Now, to determine the null in the alternative hypotheses, the hypotheses are structured in one of three ways. It's two-tailed, where you have equals and not equals. Left-tailed, equals and less than. Right-tailed is equal and greater than. Now the not equals, less than, and greater than are for the alternative, and then the null always has the equality, when we're comparing two population means. So what we're going to do is we're going to let population 1 be carpeted rooms, and population 2 be uncarpeted rooms. And then here are the TI-84 steps. We're going to enter the data into L1 and L2. So what I mean by that is, here's the data. Okay, let's go ahead and open up the calculator. And so when you want to enter the data, you're going to go to Stat, and you're going to select Edit. And if you look in L1, I've entered in the carpeted information. So we have 10.6, 10.1, 15.6, 14.5, 15.4, 6, 7.5, and then all the way down to 11.5. Now you got to be careful to make sure you don't miss anything in there, so you want to review that information correctly. And then in L2, we have 8.2, 4.2, 5.3, 13.1, 13, 7.3, 11.9, and 8.4. Now we have our data in the lists. Okay, now the next thing that we want to do is we want to now be able to determine if the normal probability plot shows a linear situation. So we're going to go ahead and go to second, and then where it says stat plot, and then we want to make sure that this plot is on. So we want to make sure that the highlight is on. Okay, and then we're going to go to type. Okay, and the type that we want a normal probability plot. So we want to go all the way to the very end and select enter. We want to make sure that L1 is listed. Okay, and then we have the following, and now let's go ahead and then hit zoom. And then we're going to go all the way down to number 9 where it says zoom stat, and that gives us the normal probability plot. So we can see here that this looks like a normal probability plot. Okay, now let's take a look at the same information. So we're going to go back to stat plot. Okay, and then we're going to go ahead and go back to the same plot, so select enter. But now we want to look at the box plot. So we're going to go down to type, and then we're going to go down here and determine if there is a outlier. So let's press enter for that. We know we have L1 again, frequency is 1, and then just press zoom, and then go ahead and then select zoom stat. And then we're going to see our box plot with we don't have any outliers. So now that works for the first part, which was our population 1, which is carpeted. Now let's go back and go to stat plot again. Okay, we're going to go plots on. We're going to go, it's already on. We're going to go down again to the very last one. And now we're going to make sure that the list is L2. So down here where it says 2, we're going to hit second. So it says L2. And now we have L2 in there, and now we're going to select zoom, and then go all the way down to number 9, and go to zoom stat, and we can see that this also gives us a normal distribution. Okay, so that's our normal distribution for uncarpeted, so that checks. Now we're going to go back to stat plot again, and then we're going to go ahead and go to number 1, plots on, and then we're going to do the box plot again. So we're going to go to type and go to this one here, select enter. We know that L2 is already answered, so let's go ahead and select enter, and then select zoom, and then go to zoom stat, and then we're going to see this box plot, which also tells us there aren't any outliers. And now we can proceed to the next step. Okay, now the next step is that what we want to be able to do is write down the information that we're looking for. Well, the information that we're looking for is the following. Okay, what is the null and what is the alternative hypothesis? Well, we know that the null is always going to contain the equality. So population mean 1 is going to equal population mean 2 when we're comparing the two means. Okay, and then we got to figure out, okay, what is the alternative hypothesis, meaning what is the claim? If we go back to the first sentence, it says a researcher wanted to determine if the carpeted rooms contain more bacteria than the uncarpeted rooms. So that means we're comparing mean 1 with mean population mean 2. So that means we're going to have a greater than here. Step number 2, we know that this is going to be a right tail. Step number 3, what is the significance level? We know the significance level is going to be 0.05. And why is that? Because they don't give us a significant level to test. So if they don't give you a significant level to test, then you automatically assume it's 0.05. Otherwise, you would use whatever is given. Okay, so now what we need to do is we need to find the test statistic. Okay, so how can we find the test statistic? Okay, and then we need to be able to draw the picture so we know exactly what this would look like. Okay, so let's go ahead and do that. And then let's find the test statistic, but we're going to use the calculator to find that information. So let's go ahead and do that. So now that we have our L1 and L2, now we're going to go to stat, and then we're going to go to tests. So we're going to scroll to the right, select test, and we're going to go down to 2 sample t-test. So going down to number 4, and then select enter. Okay, now we plugged in the data. So we're going to leave it as data. So make sure data is flashing here. List 1 is L1. List 2 is L2. The frequency is 1, and this frequency is 1. And then we want to make sure that we select the greater than symbol. So select enter. Pulled, it should be flashed as no. And then we're going to select calculate. Okay, so when we calculate, okay, we're going to be given the following information. We can see what the standard deviation is. We can see what the sample size is. So this is all the information that we need. So let's go ahead and make sure that we copy this information. Okay, and let me go ahead and do that again. So we're going to copy this first part, and then scroll down, and then we're going to copy this part here. Okay, so basically what the calculator has done is it has given us the information that we need. Okay, so the information that we need so far is the test statistic. The test statistic is 1.41. We're going to round that to 2 decimal places so we get 1.41. Okay, now technically when we want to draw and we want to be able to learn how to draw this, we have our mean of 0, and we know that our test statistic here is 1.41 because we know it's going to be greater than. So this is where the p-value is going to be. Okay, now what is the p-value? Well, here's the p-value, and we're going to round that to 3 decimal places. If we round it to 3 decimal places, we're going to get 0.090. Okay, now if we wanted to go back and see what this drawing would look like, we can actually do that. So let's go back. Okay, and let's do the test, and then go to tests, and go back to this 2-sample t-test, select enter, and we're going to go all the way down since we already had that information, and we're going to go ahead and then draw, just to verify. So when we draw, we should be able to see what this bell curve is going to look like. So there's our bell curve, and that should match what we have. So there is our drawing. Okay. Okay, now what we need to do is now we need to compare the p-value with the significance level. So let's go ahead and do that. Okay, well, in step 6, remember that the null hypothesis is rejected if the p-value is less than alpha. Well, the p-value is 0.090, and it's going to be greater than the significance level, so we do not reject the null. Therefore, we're going to say that there is not significant evidence at the alpha equals 0.05 level of significance to conclude that the carpeted rooms have more bacteria than uncarpeted rooms.